Good day everyone! Welcome sa panibago nating tutorial series. So this is Information Assurance Security 2 series. This is part 4 and for today we are going to talk about network design, elements, and components. Network design and network components play an important role in implementing the overall security of an organization. So at the end of this video, you will be able to understand and learn the network components such as we will be discussing DMZ or Demilitarized Zone, Virtual Local Area Network, Subnetting, NAT or the Network Address Translation, Remote Access, Telephony, NAC, Virtualization, Cloud Computing, IoT or the Internet of Things. And at last, we will be discussing layered security and defense in depth. And you will be learning the perimeter network boundaries that distinguish between private networks internet and the internet. So the first topic we are going to discuss is the first part in network design, elements, and components. So we have here DMZ stands for Demilitarized Zone. It is a network used to connect hosts that provide an interface to an untrusted external network, usually the internet, while keeping the internal. Private network, usually the corporate network, separated and isolated from the external network. As a system that are most vulnerable to attack are those that provide services to users outside of the local area network, such as email, web, and domain name system servers. They are quarantined inside a DMZ, from where they have limited access to the private network. Hosts in DMZ can communicate with both the internal and external network, but communications with internal network hosts is tightly restricted. Okay, next we have Virtual Local Area Networks, or also known as VLANs. So it provides an alternate method to segments of a network and in the process significantly increase the performance capability of the network and remove potential performance bottlenecks. It is also a group of computers that are connected and act as if they are on their own physical network segments, even though they may not be. For instance, suppose that you work in the 3-story building in which the advertising employees are spread over all the 3 floors. A VLAN or local area networks can let all the advertising personnel use the network resources as if they were connected on the same segment. This virtual segment can be isolated from other network segments. In effect, it would appear to the advertising group that they were on a network by themselves. Subnets may be arranged logically in a hierarchical architecture, and subnetting allows you to create smaller network inside a large network by borrowing bits from the host ID portion of the address. We can use those borrowed bits to create additional networks, resulting in smaller size networks. Okay, so we are done with the part 1, so let's proceed to part 2. Alright, so next is Network Address Translation or NAT. It defines a one-to-one address mapping when a packet passes through the security appliance and matches criteria for translation. The security appliance either assigns a static IP address, also known as static NAT, or allocates an address from a pool of addresses, or also known as dynamic NAT. Static NAT defines a fixed translation of an inside host or subnet address to a global routable address or subnet. The security appliance uses the one-to-one methodology by assigning one global IP address to an inside IP address. Thus, if 100 hosts residing on the inside network require address translation, the security appliance should be configured for 100 global IP addresses. Additionally, the inside hosts are assigned the same IP address whenever the security appliance translates the packets going through it. This is recommended solution in scenarios in which an organization provides services such as email, web, DNS, and FTP for outside users. So, Dynamic NAT assigns a random IP address from a pre-configured pool of global IP addresses. The security appliance uses a one-to-one methodology by allocating one global IP address to an inside IP address. Hence, If 100 hosts reside on the inside network, then the pool of addresses should be big enough to accommodate those hosts. This is recommended solution in scenarios in which an organization uses protocols that don't contain layer 4 information, such as generic routing encapsulation or GRE, reliable datagram protocol or RDP, and data delivery protocol or DDP. Once the security appliance has built the dynamic NAT for an inside host, any machine can connect to the assigned IP address, assuming that the security appliance allows the inbound connection, as discussed in the Monitoring Network Access Control section earlier in this chapter. Port Address Translation, or also known as PAT, defines a many-to-one address mapping when a packet passes through the security appliance and matches criteria for translation. The security appliance creates the translation table by looking at the layer 4 information in the header to distinguish between the inside host using the same global IP address. The Remote Access Service, or also known as RAS, functions can be used to make connection using a predefined RAS phonebook entry. RAS will make the call, log onto the remote computer, handle authentication, and then negotiate network connections. It is also maintains a phone book with entries for each available connection. Users can manage this phone book using the connections folder on the desktop. Each phone book entry has associated name and information on how the connection should be made, such as the phone book number, login credentials, and protocols to use. Standard RAS phone book entries are pre-installed to support the connection to the desktop PCs, such as serial port at 19200. Okay, so telephony is commonly referred as the construction or operation of telephones and telephonic systems of telecommunications in which telephonic equipment is employed in the transmission of speech or other sound between points with or without the use of wires. The term is also used frequently to refer to computer hardware, software, and computer network systems that perform functions traditionally performed by telephone equipment. In this context, the technology is especially referred to as Internet telephony. Network access control is a centralized approach to endpoint security that emphasizes network visibility and restrictive access management by implementing policies across all users and devices. It is also defines and implements rules that specify which users and devices can access the network using a set of protocols and policies. In most situations, a network access control system is built to prohibit non-compliant and unauthorized devices access to the network. Based on a number of factors such as a system health, role-based variables, network access control enables you to deny or allow network access. Network access control helps to identify network access policies based on tasks within the company and enforce them. As an outcome, network access control should be configured so that employees also have access to the data required to complete their job functions. So we have here general capabilities of network access control solutions. First is policy lifecycle management. It enforces policies for all operating scenarios without requiring separate products or additional modules. And profiling and visibility recognizes and profiles users and their device before malicious code can cause damage. And guest networking access manage guests through a customizable self-service portal that includes guest registration, guest authentication, guest sponsoring, and a guest management portal. Next is security posture check. It evaluates security policy compliance by user type, device type, and operating system. Next, we have incident response. Mitigates network threats by enforcing security policies that block, isolate, and repair non-compliant machines without administrator attention. And bidirectional integration, integrate with other security and network solutions through the open API. Next, for the types of network access control, we have agent-based. It is a solutions rely on more detailed information for every device connected to a network and to allow for more granular policies when authenticating devices. These network access control tools may deny device access based on factors like insufficient security software or prohibited apps installed on the device. The downside is that all devices on an agent-based system must be pre-enrolled on the Network Access Control tool to apply policies. Agentless solutions provide more flexibility when identifying and authenticating devices. These solutions will discover devices as they join a network and determine the proper policies to apply them. Agentless systems are often integrated with other products such as intrusion prevention systems to bolster the authentication processes. Hardware-based approach to manage user authentication, network access, data protection, and more that takes security to higher level than software-based security. Hardware-based solution that integrates with third-party vendors. The key with network access control is all computers are guessed until they are validated as compliant. Typically, the only way to validate compliance is on managed computers. So, this solution protects the corporate network from visitors' computers like consultants. These computers would only have access to the guest virtual LAN, which might have access to the internet or a portal. Okay? So next, Dynamic Network Access Control. Dynamic Network Access Control offers centralized management, flexible policies, granular quarantining and monitoring, and remediation of unhealthy systems. Dynamic NAC hardens the existing network by making some of the PCs enforcers that monitor and control access to the network. Enforcers report and quarantine unauthorized devices like rogue endpoints and unhealthy PCs. So let's move on to the part 3 in network design, elements, and components. Okay, so virtualization creates a simulated or virtual computing environment as opposed to a physical environment. Virtualization often includes computer-generated versions of hardware, operating system, storage devices, and more. This allows organizations to partition a single physical computer or server into several virtual machines. Each virtual machine can interact independently and run different operating systems or applications while sharing the resources of a single host machine. By creating multiple resources from a single computer or server, virtualization improves scalability and workloads while resulting in the use of fewer overall servers, less energy consumption, and less infrastructure costs and maintenance. And the first types of virtualization is server virtualization. Servers are computers designed to process a high volume of specific tasks really well. So other computers like laptops and desktops can do a variety of other tasks. Virtualizing a server lets it to do more of those specific functions and involves partitioning it so the components can be used to serve multiple functions. Okay? Next is the network functions virtualization or NFV. It separates the network's key functions like directory services, file sharing, and IP configuration, so they can be distributed among environments. Once software functions are independent of the physical machines they once live on, specific functions can be packaged together into a new network and assigned to an environment. Virtualizing networks reduces the number of physical components like switches, routers, servers, cables, and hubs that are needed to create multiple dependent networks. And it's particularly popular in the telecommunications industry. And we have the desktop virtualization, easily confused with operating system virtualization, which allow you to deploy multiple operating systems on a single machine desktop. Virtualization allows a central administrator to deploy simulated desktop environments to hundreds of physical machines at once, unlike traditional desktop environments that are physically installed, configured, and updated on each machine. Desktop virtualization allows admins to perform mass configurations, updates, and security checks on all virtual desktops. Okay? So, data virtualization is a data that spreads all over can be consolidated into a single source. Data virtualization allows companies to treat data as a dynamic supply providing processing capabilities that can bring together data from multiple resources and easily accommodate new data sources and transform data according to user needs. Data virtualization tools sit in front of multiple data sources and allows them to treat it as a single source, delivering the needed data in the required form at the right time to any application user. And the last one is operating system virtualization. It happens at the kernel. The central task managers of operating systems, it is a useful way to run Linux and Windows environments side by side. Enterprises can also push virtual operating systems to computers, which reduces bulk hardware costs since the computers don't require such high out-of-the-box capabilities. It also increases security since all virtual instances can be monitored and isolated and limits the time spent on IT services like software updates. Okay? So the next is cloud computing. Cloud computing is the delivery of computing services including servers, storage, databases, networking, software, analytics, intelligence over the internet to offer faster innovation, flexible resources, and economies of scale. And we have three types of cloud computing. So, software as a service or SaaS is a method for delivering software applications over the internet, on demand, and typically on a subscription basis. With SaaS, it is a cloud provider's host and manage the software application and underlying infrastructure, and it can handle any maintenance like software upgrades and security patching. Users connect to the application over the internet, usually with a web browser on their phone, tablet, or PC. Infrastructure as a service, or IaaS, is a type of cloud computing service that offers essential compute, storage, and networking resources on demand on a pay-as-you-go basis. IaaS lets you bypass the cost and complexity of buying and managing physical servers and data center infrastructure. Each resource is offered as a separate service component and you only pay for particular resource for as long as you need it. Platform as a service refers to cloud computing services that supply an on-demand environment for developing, testing, delivering, and managing software applications. Next, we have PaaS. PaaS is designed to make it easier for developers to quickly create web or mobile apps without worrying about setting up or managing the underlying infrastructure of servers, storage, network, and databases needed for development. So we have here public cloud, private cloud, hybrid cloud, and multi-cloud. So public model is a developer environment in which a set of predetermined infrastructure is shared among a group of tenants. Public environments are hosted by vendors that often provide both public and private environments. The hosting provider maintains the infrastructure, installs updates and patches, and manages the application software as part of the service. The biggest advantage of using public environment is the low initial cost. And the disadvantage of public cloud-based developer environment doesn't support agile methods as well as private environments do. The private model is a developer environment in which all the cloud-based computing infrastructure is dedicated to one user organization. This cloud-based developer environment can be hosted by the using organization or by a vendor that offers private virtual hosting services. In a private virtual environment, the using organization usually manages the operations within the cloud-based developer environment. Okay, next we have the hybrid model. Hybrid model is a combination of multiple cloud computing environments that are linked together to appear a single environment. The most common way to link those connected environments is through application programming interfaces or APIs. API allowed cloud developers to install software applications in one environment and use them in another connected environment. Multi-cloud refers to the presence of more than one cloud deployment of the same type, public model and private model sourced from different vendors. A multi-cloud approach could involve two public cloud environments or two private cloud environments. Okay, so let's proceed to the part 4 in network design, elements, and components. So we have here IoT or Internet of Things. IoT enables your organization to analyze and act on data, allowing you to make smart decisions in real time, with the timely and relevant insights about your business and customers that can come with these new sources of data. There is great potential for industries of all kinds, including manufacturing, transportation, energy, agriculture, retail, and government, to operate more efficiently and provide new value to customers by implementing the right IoT solution. So we have here 10 predictions about the future of Internet of Things. First, by 2025, it is estimated that there will be more than 21 billion Internet of Things devices. A quick look back shows where Internet of Things devices are going. Consider in 2016, there were more than 4 billion things connected to the Internet. According to IoT Analytics, fast forward to 2021, the market will increase to nearly 11.6 billion IoT devices. 2. Cybercriminals will continue to use IoT devices to facilitate DDoS attacks. In 2016, the world was introduced to the first Internet of Things malware as a strain of malicious software that can infect connected devices such as DVRs, security cameras, and more. The Mirai malware accessed the devices using default password and usernames. What happened next? The malware turned the affected devices into a botnet to facilitate a distributed denial of service or the DDoS attack, which aims to overwhelm websites with internet traffic. The attack needed up flooding one of the largest website hosting companies in the world, bringing a variety of major, well-known websites and services to a halt for hours. This particular strain of malware is called open source, which means the code is available for anyone to modify. 3. More cities will become smart. Consumers won't be the only ones using IoT devices. Cities and companies will increasingly adopt smart technologies to save time and money. That means cities will be able to automate, remotely manage, and collect data through visitor KIOS, video camera surveillance systems, bike rental stations, and taxis. Fourth, we have here artificial intelligence. AI will continue to become a bigger thing. Smart home hubs, thermostats, lighting systems, and even coffee makers collect data on your habits and patterns of usage. When you set up the voice control devices, you allow them to record what you say to them and store those recordings in the cloud. In most cases, the data is collected to help facilitate what is called machine learning. Machine learning is a type of artificial intelligence that helps computers learn without someone having to program them. The computers are programmed in a way that focuses on data that they receive. This new data helps the machine learn what your references are and adjust itself accordingly. For instance, when a video website suggests a movie that you might like, that it's likely learned your preferences based on your past choices. Okay, and for the fifth is routers. Routers will continue to become more secure and smarter. Most consumer IoT devices reside in the home and can't have security software installed on them. They can be vulnerable to attacks. Why? A lot of manufacturers work to get their IoT products to market quickly, so security may be an afterthought. This is where the home router plays a very important role. The router is essentially the entry point of the internet into your home. While many of your connected devices cannot be protected, the router has the ability to provide protection at the entry point. A conventional router provides some security such as a password protection, firewalls, and the ability to configure them to only allow certain devices on your network. Router makers will likely continue to seek new ways to boost security. Okay, so 6 is 5G networks. 5G networks will continue to fuel IoT growth. Major wireless carriers will continue to roll out 5G networks. 5G, or the 5th generation cellular wireless, promises greater speed and the ability to connect more smart devices at the same time. Faster networks mean the data accumulated by your smart devices will be gathered, analyzed, and managed to a higher degree that will fuel innovation and companies that make IoT devices and boost consumer demand for new products. Okay? 7 is cars. Cars will get even smarter. The arrival of 5G will shift the auto industry into a higher gear. The development of driverless cars as well as the connected vehicles already on the road will benefit from data moving faster. Okay? You might not think of your car as an Internet of Things device, but new cars will increasingly analyze your data and connect with other IoT devices, including other high-tech vehicles on four wheels. And for the eighth is, 5G's arrival will also open the door to new privacy and security concerns in time. More 5G IoT devices will connect directly to the 5G network than via a Wi-Fi router. This trend will make those devices more vulnerable to direct attack. For home users, it will become more difficult to monitor all IoT devices because they will bypass a central router. On a broader scale, the increased reliance on cloud-based storage will give attackers new targets to attempt to breach. Okay? So ninth is IoT-based DDoS attacks will take on more dangerous form. Botnet-powered distributed denial of service or DDoS attacks have used infected IoT devices to bring down websites. IoT devices can be used to direct other attacks. For instance, there may be future attempts to weaponize IoT devices. A possible example would be a nation shutting down home thermostats in an enemy state during a harsh winter. So that would be dangerous. Okay, next is security and privacy. Security and privacy concerns will drive legislation and regulatory activity. The increase in IoT devices is just one reason security and privacy concerns are rising. Okay? In mid-2018, the European Union implemented the General Data Protection Regulation or GDPR. GDPR has led to similar security and privacy initiatives in several nations around the world. Next, we have defense in depth. Defense in depth is a security architecture is based controls that are designed to protect the physical, technical, and administrative aspects of your network. Defense in depth is an information assurance strategy that provides multiple redundant defensive measures in case a security control fails or vulnerability exploited. Okay, next is physical controls. Physical controls are the security measures that protected IT systems from physical harm. Example of physical controls include security guards and locked doors. Technical controls are the protection methods that secure network system. Hardware, software, and network level protection is included within the company's specific technical controls. Cybersecurity efforts including layered security is live in this category. Administrative controls are the policies and procedures put in place by an organization directed at the employees, training employees to make certain to label sensitive information as confidential or private files in proper folders, and examples of administrative control. Next, access measures, an essential part of the defense in-depth layers. These are procedures put into place through either policies or software that regulate who enters your company network and to what extent. Essential components include virtual private networks, authentication controls, biometric scanning, and privilege access management. Data protection is an example of defense in-depth layers of cybersecurity. Its purpose, as the name implies, is to guard the integrity of information resources within a company network. Some processes pertaining to it that you can include in your strategy are data hashing, encryption, and address. And it seems work together to prevent the most dangerous types of network traffic and to help confirm a user's identity. They work together along with your email spam filtering application to block the vast majority of threats targeting your business. Ayan. So that's it for this video and hoping na may natutunan kayo. At kung may mga katanungan kayo, contact nyo lang ako through email or chat. Okay? So see you on the next video.